Yes, there are individuals utilizing Level 2 personal protective equipment, or PPE, for arc flash protection on their jobs. The necessity for Level 2 PPE typically arises when working with energized electrical equipment where an arc flash hazard exists. This includes tasks involving hot control panels, switchgear, and various other electrical equipment. The particular level of PPE demanded for a specific task hinges on several factors. Firstly, the voltage of the equipment plays a crucial role. Secondly, the distance from the potential hazard is a significant consideration. And thirdly, the duration of potential exposure influences the PPE level required. As a general rule, equipment operating at higher voltages necessitates a higher level of PPE. The application of Level 2 PPE is not geographically restricted. Its adoption is increasing nationwide as awareness grows among employers regarding arc flash risks and the paramount importance of employee protection. Examples of tasks where Level 2 PPE may be necessary include 1. Troubleshooting hot control panels, 2. Replacing fuses or circuit breakers, 3. Performing maintenance on energized switchgear, 4. Installing or removing electrical equipment, and 5. Working on live overhead lines. It's essential to understand that PPE is just one component of a comprehensive arc flash safety program. Employers bear the responsibility of implementing additional safety measures to safeguard their workforce. These measures encompass providing thorough training, conducting detailed hazard analyses, and enforcing adherence to proper work practices. Arc flash incidents pose significant risks to electrical workers, potentially resulting in severe burns, electrical shock, and even fatalities. To mitigate these risks, a multifaceted approach to safety is crucial. This approach should integrate engineering controls, administrative procedures, and the utilization of appropriate personal protective equipment. Engineering controls involve designing and implementing equipment and systems that inherently reduce the likelihood of arc flash events. Examples include arc-resistant switchgear, remote racking systems, and current-limiting devices. Administrative controls encompass the establishment and enforcement of safe work practices such as lockout/tagout procedures, energized electrical work permits, and regular safety audits. These practices aim to minimize worker exposure to electrical hazards. Personal protective equipment serves as the last line of defense, providing a barrier between the worker and the potential arc flash hazard. The selection of appropriate PPE is critical, and it must be based on a thorough hazard assessment. This assessment should consider factors such as the incident energy level, the working distance, and the potential for exposure to other hazards. Level 2 PPE typically includes a flame-resistant shirt and pants, arc-rated face shield or hood, insulated gloves, and safety footwear. The specific arc rating of the PPE must meet or exceed the calculated incident energy level for the task. Regular inspection and maintenance of PPE are essential to ensure its effectiveness. Damaged or worn PPE should be immediately replaced. Training is a cornerstone of any effective arc flash safety program. Workers must be thoroughly trained on the hazards of arc flash, the proper use of PPE, and safe work practices. Training should be conducted regularly and updated to reflect changes in equipment, procedures, or regulations. A comprehensive arc flash hazard analysis is essential for identifying potential arc flash hazards and determining the appropriate level of protection. The analysis should be conducted by a qualified person and should include a review of the electrical system, operating procedures, and maintenance records. The results of the hazard analysis should be documented and used to develop safe work practices and select appropriate PPE. Proper work practices are critical for minimizing the risk of arc flash incidents. These practices include de-energizing equipment whenever possible, maintaining safe working distances, using insulated tools, and avoiding conductive objects near energized equipment. Lockout/tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair. These procedures involve disconnecting the equipment from all power sources and attaching locks and tags to prevent unauthorized reconnection. Energized electrical work permits are required for any work performed on energized equipment. The permit should specify the work to be performed, the hazards involved, and the precautions to be taken. Regular safety audits are essential for ensuring that the arc flash safety program is effective and that workers are following safe work practices. The audit should be conducted by a qualified person and should include a review of the written program, training records, hazard analysis, and work practices. In the United States, arc flash safety is regulated by the Occupational Safety and Health Administration (OSHA). OSHA regulations require employers to protect their employees from arc flash hazards. These regulations include requirements for hazard assessment, training, PPE, and safe work practices. The National Fire Protection Association (NFPA) also publishes standards related to arc flash safety. NFPA 70E, Standard for Electrical Safety in the Workplace, provides detailed guidance on how to protect workers from arc flash hazards. This standard is widely recognized and used by employers in the United States. Understanding arc flash incident energy is crucial. Incident energy is the amount of thermal energy produced during an arc flash event, typically measured in calories per square centimeter cal/cm2. This value is a key factor in determining the appropriate level of PPE required for a specific task. Higher incident energy levels necessitate PPE with a higher arc rating. Arc rating, expressed in cal/cm2, indicates the level of protection provided by PPE. It represents the maximum incident energy exposure the PPE can withstand without causing second-degree burns. When selecting PPE, it is imperative to ensure that the arc rating meets or exceeds the calculated incident energy for the task. Various methods exist for calculating incident energy, including software programs and online calculators. These tools consider factors such as voltage, fault current, and working distance to estimate the potential thermal energy exposure. When performing an arc flash hazard assessment, it's crucial to consider all potential sources of electrical energy. This includes not only the main power supply but also any backup generators, uninterruptible power supplies or UPS, and other energy sources that could contribute to an arc flash event. The assessment should also take into account the configuration of the electrical system, including the presence of any protective devices such as fuses and circuit breakers. The location of these devices and their clearing times can significantly impact the incident energy level. Working distance is a critical factor in determining the severity of an arc flash exposure. As the distance from the arc flash increases, the incident energy decreases. Therefore, maintaining a safe working distance is an important strategy for minimizing the risk of injury. The safe working distance should be determined based on the calculated incident energy level and the arc rating of the PPE being worn. Proper tool selection and maintenance are also essential for arc flash safety. Insulated tools should be used whenever working on energized equipment. These tools provide a barrier between the worker and the electrical current, reducing the risk of electric shock. Tools should be regularly inspected for damage and replaced as needed. Damaged or worn tools can compromise their insulation and increase the risk of electrical contact. Regular inspections of electrical equipment are crucial for identifying potential hazards before they lead to arc flash incidents. Inspections should include a visual examination of wiring, connections, and components for signs of damage, overheating, or corrosion. Any identified problems should be promptly addressed to prevent equipment failure and potential arc flash events. In addition to the specific requirements for arc flash PPE, general safety practices should always be followed when working with electrical equipment. These practices include wearing appropriate eye protection, such as safety glasses or goggles to protect against flying debris and arc flash radiation. Hearing protection should also be worn in areas with high noise levels. Loose clothing and jewelry should be avoided, as they can increase the risk of entanglement or electrical contact. Safe work practices also include maintaining a clean and organized work area, free from clutter and obstructions. This helps to prevent trips, falls, and other accidents. It also makes it easier to identify and address potential hazards. Emergency response procedures should be in place in case of an arc flash incident. These procedures should include instructions for providing first aid to injured workers, contacting emergency services, and investigating the cause of the incident. All workers should be familiar with the emergency response procedures and know how to respond in the event of an arc flash. Continuous improvement is essential for maintaining a strong arc flash safety program. The program should be regularly reviewed and updated to reflect changes in equipment, procedures, regulations, or best practices. Feedback from workers should be solicited and used to identify areas for improvement. By continuously striving to improve the arc flash safety program, employers can create a safer work environment for their employees and reduce the risk of arc flash incidents. The arc flash boundary is a critical concept in electrical safety. It is the distance from exposed energized electrical conductors or circuit parts where a person could receive a second-degree burn if an arc flash were to occur. The arc flash boundary is determined by calculating the incident energy at various distances from the potential arc flash source. The greater the incident energy, the larger the arc flash boundary. No unqualified person should cross the arc flash boundary without appropriate PPE. Qualified persons are those who have been trained and demonstrated skills and knowledge in the construction and operation of electrical equipment and installations and have received safety training to identify and avoid the hazards involved. The limited approach boundary is another important concept. This is the distance from an exposed energized electrical conductor or circuit part within which a person could be exposed to a shock hazard. Only qualified persons are allowed to approach closer than the limited approach boundary. The prohibited approach boundary is the distance from an exposed energized electrical conductor or circuit part within which work is considered the same as making direct contact with the energized part. Only qualified persons with appropriate training and PPE are allowed within this boundary. Establishing and maintaining a robust electrical safety program, including detailed arc flash analysis and comprehensive training, is not merely a regulatory obligation but also a moral imperative. Protecting electrical workers from the potentially devastating consequences of arc flash incidents requires a sustained commitment to safety at all levels of the organization. By implementing engineering controls, administrative procedures, and providing appropriate PPE, employers can create a safer work environment and prevent injuries and fatalities. The ongoing evolution of electrical safety standards and best practices necessitates continuous learning and adaptation. Staying informed about the latest regulations, technological advancements, and industry trends is crucial for maintaining an effective arc flash safety program. Participating in industry conferences, attending training courses, and networking with other safety professionals can help to ensure that the program remains current and relevant. Investing in arc flash safety is an investment in the well-being of electrical workers and the long-term success of the organization. A strong safety culture fosters a sense of trust and respect between employers and employees, leading to increased productivity, reduced absenteeism, and improved morale. Moreover, preventing arc flash incidents can save significant costs associated with medical expenses, lost productivity, and potential legal liabilities. Ultimately, the goal of arc flash safety is to create a work environment where electrical workers can perform their duties safely and confidently, knowing that they are protected from the hazards of electricity. This requires a collaborative effort from all stakeholders, including employers, employees, safety professionals, and regulatory agencies. By working together, we can make a significant difference in preventing arc flash injuries and fatalities and ensuring a safer future for all electrical workers. Employers need to provide adequate resources for electrical safety programs. This includes funding for training, PPE, and hazard assessment. It also includes time for employees to participate in safety activities. Employees should be empowered to speak up about safety concerns. They should feel comfortable reporting hazards without fear of retaliation. A strong safety culture is one in which everyone is responsible for safety. Communication is essential for a successful electrical safety program. Employers should communicate safety information to employees regularly. This can be done through toolbox talks, safety meetings, and written materials. Employees should also communicate safety concerns to their supervisors. A thorough job hazard analysis, or JHA, should always be conducted prior to starting work. A JHA is a systematic process for identifying potential hazards associated with a particular job task. It involves breaking down the job into individual steps, identifying the hazards associated with each step, and developing controls to mitigate those hazards. A JHA should be documented and reviewed regularly. A job safety analysis, or JSA, is similar to a JHA. Both are designed to identify hazards and develop controls. The term JSA is often used interchangeably with JHA. The hierarchy of controls is a system for prioritizing hazard controls. The most effective controls are those that eliminate the hazard completely. If elimination is not possible, the next most effective controls are those that substitute a less hazardous alternative. Engineering controls are physical changes to the workplace that reduce or eliminate hazards. Administrative controls are policies and procedures that reduce or eliminate hazards. Personal protective equipment is the least effective control and should only be used as a last resort. Electrical safety audit should be conducted regularly to ensure that the electrical safety program is effective. The audit should be conducted by a qualified person and should include a review of the written program, training records, hazard analysis, and work practices. The results of the audit should be documented and used to improve the electrical safety program. The qualified electrical worker should be able to distinguish energized parts from non-energized parts. The qualified electrical worker should also be able to determine the nominal voltage of energized parts. The qualified electrical worker should be familiar with the proper use of special precautionary techniques, PPE, insulated and insulating tools and equipment. An electrically safe work condition is achieved when the equipment is de-energized and properly locked out and tagged out. Lockout-tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair. These procedures involve disconnecting the equipment from all power sources and attaching locks and tags to prevent unauthorized reconnection.